Welcome back. In this video, we are going to be looking at graphing logarithmic functions. When we graph logarithmic functions, they're written in the form y is equal to a times log base b of x minus h plus k. We have a couple things about this. Our base has to be a positive number not equal to 1. X minus h, whatever the input of our log is, has to be positive. A, h, and k do exactly the same things that they've done all year. A is going to be a vertical stretch or shrink, as well as a flip if it's negative, a flip across the x-axis. H is going to be a horizontal shift left or right, so x plus 4 would be a shift left 4. K will be a vertical shift up and down. We're also going to use a few key logs. Log base b of b is equal to 1. This is equivalent to saying b to the 1 is equal to b. We're also going to use log base b of 1 is equal to 0. That is the same thing as saying b to the 0 is equal to 1. b to the 0 is equal to 1. And the last one we'll use is log base b of 1 over b is equal to negative 1. That's the same thing as saying b to the negative 1 is equal to 1 over b. So these are equivalent to the same things we used when graphing exponential functions. I want to keep these ready for us for when we get to our graphing problem. The example that we're going to graph here is going to be f of x is equal to 5 times log base 6 of x minus 3 minus 4. So I want to kind of look at a few things here. My a value is 5, my h value is 3, my k value is negative 4. The base of this logarithmic function is 6, and the input for my logarithmic function is x minus 3. It's really important that we identify these two things here because we're going to use them a lot. Whenever we start graphing logarithmic functions, the best place to start is figuring out what our domain is. Our domain is going to be restricted by what we are allowed to put inside our log function. The input to our log must be positive. So my input to my log is x minus 3, so x has to be greater than 3. That's going to be my domain. The range for all of these, range for logarithmic functions is always going to be all real numbers. When we graphed exponential functions, we said that the domain was all real numbers and the range was restricted. Logarithmic are the inverse, so it's going to be the reverse of that. Our range will be all real numbers and the domain will be restricted. We will also always have a vertical asymptote in these functions, in logarithmic functions. To find our asymptote, we take our domain and turn it into an equal sign. So x equals 3 becomes my vertical asymptote. So here is my vertical asymptote. X is equal to 3. Now I need to make a table of values. I'm going to make 3 columns to my table. The first is input, then x, then y. Now the input piece of this table is really, really important. We are going to have 3 main inputs that relate to these values. In the same way that we chose what we wanted the exponent of our exponential functions to be, we are going to choose what we want the input of our logarithmic function to be. I don't know what log base 6 of 5 is, so I really don't want to have to evaluate that. I need a calculator. If I don't have a calculator, which I'm not going to if I'm graphing by hand, I want to stick to logs that I know. These are 3 logs that I know, so I want to try to use these logs over here. The first input I want to use is that I want to input the base. The base of my function is 6, so I want the input to my log to be 6. And the input to my log is x minus 3, so I add 3 to each side. So I want my first input, my first x value, to be 9. If I input 9, I get 5 times log base 6 of 9 minus 3 minus 4. So that is 5 times log base 6 of 6 minus 4. Log base 6 of 6 is equal to 1. So this is just 5 times 1 minus 4, or 5 minus 4 is 1. So I have the point 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. That's the point 9, 1 on my graph. So this was my key input number 1, B. My next input is that I want the input to my log to be 1 because I know log base anything of 1 is equal to 0. So if I want my input to be 1, that's going to be x minus 3. Add 3 to each side. My input there, x should be equal to 4. So 5 times log base 6 of 4 minus 3 minus 4 is equal to 5 times log base 6 of 1 minus 4. Log base 6 of 1 will be equal to 0. So this is 5 times 0 minus 4 ends up giving me negative 4. So I have the point 4, negative 4, which is right there. And the last input I want is 1 over b. Because again, I know log base b of 1 over b. So that is 1 over 6 is equal to x minus 3. Add 3 to each side, and this becomes 3 and 1/6. So that is 5 times log base 6 of 3 and 1/6 minus 3 minus 4 is 5 times log base 6 of 1/6 minus 4. Log base 6 of 1 over 6 will be equal to negative 1. Negative 5 minus 4 will be negative 9. So 3 and 1/6 will be like there, and negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 will be right there. So my graph will look like that. Approaching the vertical asymptote down here, curving and heading off to the right over there. I've already identified my domain and range. My graph, the picture that I've graphed, matches my expected domain and range, and I have my 3 points graph.